Hello folks, Prasad Domla here. In this video, I'll show you how to develop, test and deploy TypeScript-based Lambda functions using AWS CDK. So let's get started. We'll be developing Node.js-based Lambda functions written in TypeScript, which will be compiled to JavaScript before deployment. In this video, we'll be creating public Lambda functions as well as private Lambda functions, that is Lambda functions within VPC. For testing purposes, I'll show you how to use SAM local to test your Lambda functions locally. I'll also show you how to package and deploy Lambda layers, where you can put some common utility functions or files that can be shared across all your Lambda functions. I'll be using CDK version 2 for this demo. Make sure you're using version 2 as well if you're following along this tutorial, as there are some significant changes between version 1 and version 2. Let me first show you the CDK project I initialized, which creates the folder structure and some boilerplate code. I'm not going through the details of this structure. You can watch my other video where I explain the initialization process and the project structure in detail. I'll leave the link in the description. Also, all the code I'm using in this demo will be in my Git repo. You can find the link in the description as well. So this is my default folder structure that's created as part of CDK init command. I need to make some changes to the default project files to set up my environment. Again, I won't go into details of these changes as I have explained it in my other video. So I would strongly recommend to watch that video if you haven't already. First, let's have a look at our cdk.json file. So I'm adding globals and environments to my default context here. Within globals, I define my app name and region. I'll be using this app name for naming my AWS resources. Within the environments array, I just have one environment at the moment where I define my environment name, branch name, and AWS account number. You can have as many environments as you need here. And deployments are based on the Git branch we are currently on. That is, if you deploy from a develop branch, it deploys to your dev environment. And if you deploy from a production branch, it deploys to your production environment. Now let's add a type definition for our CDK context. So I'm creating a types file here and a definition called CDK context. Now let's look at the default boilerplate stack created as part of the initialization. By default, the name of the stack will be same as your project name, which is YT TypeScript Lambda CDK in my case. Let's first rename it. I'm calling my stack as Lambda stack. Also, I'll rename my class to Lambda stack as well to keep it consistent. One more thing I want to do here is to import CDK context type we created earlier and use it as an argument in our constructor, because we'll be using the values from CDK context while defining our resources. We shall be passing this context object when we initialize this stack. TypeScript throws an error here as we can't have optional parameters before required parameters. So I'll just make props as required parameter here to get rid of that error. And I'll remove the boilerplate code that we don't need. Let's leave this file here and we'll come back to this file later in this video. We'll be defining all our Lambda resources in this file later. Next, coming to the entry point TypeScript file within the bin directory, we can see that we have an error here. That's because we renamed our stack. Let's fix that first. Next, I'm adding a couple of imports, git branch, that is to identify the current branch we are on, and the type we just defined earlier, which is CDK context. It's showing an error as I didn't install the git branch npm package yet. So let me do that now. So I'm installing the git branch and corresponding types. Next, I'm deleting the default boilerplate code and adding a function called getContext, which returns us the CDK context specific to our environment based on our git branch. Here in this function, I'm first identifying the current branch using a git branch npm package and fetching the environment from the environments array and the global parameters using the try get context method provided by our CDK app. Next, I'm adding a function which actually creates our stacks. I'm calling it create stacks. Here we are creating a new instance of CDK app and fetching the environment specific context using the get context method. Next, I'm defining a tags object. These tags will be added to all the resources in the stack when we pass it during our stack initialization. Then I'm defining the stack props, which contains the environment. That's our AWS region and account number. And we are again fetching these values from our context. I'm also adding a stack name and description to my stack. And the stack name is in the format of app name -stack -environment. And these values are from my CDK context. And finally, I'm adding the tags object to my stack props. Last thing we need to do is to initialize the stack itself. I'm adding a new instance of Lambda stack and passing in the CDK app as scope. the ID of the stack within our CDK project, which I'm keeping it same as the stack name, and finally the stack props and the context object. That's how you define a stack with all the data required to create a stack. Finally, don't forget to call the create stacks function. Now we are ready to define the resources in our stack. As you might already know, we need an IAM role to provide necessary permissions for our Lambda functions to access other AWS services. Here we'll create a single IAM role in our app and use it for all our Lambda functions for this demo. Next, as I mentioned in the beginning of this video, we'll be creating two Lambda functions, one private and the other public. For private Lambda functions, we need a VPC with private subnets and respective security group. I already have a VPC and private subnets within that VPC, so I'll just import those and use it in our Lambda stack. So you don't need to create a new VPC and subnets. We can simply import existing resources and use them in our CDK projects. Next, we shall define our Lambda layer and attach it to our Lambda functions. I'll put some utility functions in the layer for the sake of this demo. Now let's start defining these resources in our stack. Let's start with IAM resources by importing IAM from CDK lib. And I'm pasting the code here for defining the IAM role. All these props can be found in the documentation. It's strongly recommended to take a look at the documentation and use appropriate props to suit your requirements. Make sure you're using the right version of the documentation, as there are some differences between different versions. The role name is set as appname-lambda role-environment. You can see the values are picked from the CDK context. So I'm adding some description here. Next, we need to make the role to be assumed by Lambda service. We can do that using the assumed by prop and pointing it to service principal, which is lambda.amazonaws.com. Finally, I'm adding manage policies and providing read-only access to the IAM role. You can add additional manage policies to this array. This is one way of assigning permissions to the IAM role. We can also add custom manage policies using iam.managepolicy.from manage policy ARN or manage policy name. You can also define inline policies as well. You can use attach inline policy method and define your inline policy statements like this. Here I am adding an inline policy called Lambda execution access and providing some CloudWatch related permissions. And we can attach it to the Lambda role we defined above using attach inline policy method. You can see that the statements is an array, so you can add multiple policy statements to this array as per your security requirements. So those are our IAM resources. Now let's import our VPC and subnets for our private Lambda functions and create a security group. So before defining our VPC resources, we need to add our VPC and subnet IDs to our context. So within my cdk.json file, I'm adding VPC details corresponding to my dev AWS account. And if you have additional environments defined here, you can add the details for those respective environments. We also need to update our CDK context type definition to include the VPC details. Let's do that now. So the VPC ID and CIDR will be a string and private subnet IDs will be a string array. Coming back to our stack definition, VPC construct is part of EC2. So let's import EC2 from CDK lib and paste the code for VPC import. So we are using a method called from lookup and passing in the VPC ID from our CDK context. Next, let's import private subnets based on the subnet IDs from CDK context. Here we are using from subnet ID method and creating an array of private subnets. Now let's define our Lambda security group. I'm passing in the VPC, allowing all outbound traffic and setting the name of our security group. Next, I'm adding an ingress rule to allow traffic from VPC CIDR block and all TCP ports. And obviously you can customize these rules as per your security requirements. Next, let's define our Lambda layer. I'll add a folder called Lambda layer and add a utils.ts file within that folder. So this whole folder will be packaged and deployed as a Lambda layer. So you can add any additional files that you want to be part of the layer within this folder. For the sake of this demo, I'll add some utility functions to log messages. So this is just an example, so you can add any common functions that you want to share across your Lambda functions within this utils file. These are simple logging functions which takes message and title and prints that message using console.info or error or warning or debug. And I'll show you how to use these functions from this Lambda layer within our Lambda functions later in this video. Now let's get back to our stack file and define our Lambda layer. So let's first import Lambda from CDK lib And CDK also provides a construct called Node.js function to define our Node.js Lambda functions. So I'm importing that as well. Now let me paste the code for the Lambda layer. Here I'm pointing the code prop to the folder that we just created called Lambda layer. And I'm using lambda.code.from asset method. I'm also adding Node.js 14 as compatible runtime. If you're using different version of Node.js, you can select that from the list here. Finally, I'm adding some description to my Lambda layer. So those are the resources required for our Lambda functions. Next, let's define the actual Lambda functions itself. So we can define the Lambda functions one by one within this file, but we'll end up with a lot of duplicate code if we define each Lambda function individually within the stack file. So the way I would like to create my Lambda functions is to define a config, and the stack file can read that config and generate our Lambda function definitions dynamically. That way, all we need to modify is the Lambda config without touching the stack file if we need to add any new Lambda functions. So let me show you how to do that. First, let me create a lambdaconfig.ts file which holds all our Lambda config within the lib directory. And our Lambda definition will hold all the props required to define a Lambda function. So let's create a type definition for our Lambda config. So within our types file, I'll add a new type called Lambda definition. And Lambda definition will have a name, which is required parameter. And optionally, we can have memory in megabytes and timeout in minutes and any environment variables we need to add to our Lambda function. And finally, whether our Lambda function is private or not. Let's now import this in our config file. Next, I'm adding default values for memory and timeout. And then I'm adding a function called as getLambdaDefinitions, which basically returns a Lambda definitions array. So this function will take CDK context as input. We can use the values from this CDK context to define our Lambda environment variables. So let's first import CDK context from types and paste the code for our getLambdaDefinitions function. As you can see, we are passing context as a parameter and it returns a Lambda definition array. I'm defining my Lambda definitions and returning it. As you can see, I defined two Lambda functions, one private and one public, by setting isPrivate to either true or false. You can also see that I'm setting the memory and timeout for the private function. As we didn't set these values for the public function, it uses the default values which we defined here. I'm also setting the environment for my Lambda functions, and for the sake of this demo, I'm just adding the values from CDK context into Lambda environment variables. You can add as many Lambda functions as required into this definitions array. Next, we need another function to return us the Node.js function props. So these are the actual props that a Node.js function construct needs in order to create our Lambda function. So let's first import the type definition for Node.js function props from CDK lib. We also need to import Lambda and IAM from CDK lib, as we'll be using constructs from those packages. So this get function props takes four parameters: Lambda definition, which we defined above, Lambda role, Lambda layer, and CDK context, and returns a Node.js function props. Within this Node.js function props object, we have a function name, which I'm setting it as app name -function name -environment. Then for the entry point, I'm pointing it to the TypeScript file with the function name within the Lambda handlers directory. So let's create that directory and TypeScript files where we'll write our Lambda function code. Make sure the names of these TypeScript files are same as the names we defined in our Lambda config. In my case here, the files are called as private-function.ts and public-function.ts. Coming back to our config file, I'm setting the memory either from Lambda definition or the default value depending on whether you define the memory in your Lambda definition. And the same goes for timeout as well. Next, I'm just setting the environment from the Lambda definition. And finally, Lambda role and Lambda layers. As you can see, Lambda layers key is an array, which means you can add multiple layers to your Lambda functions. And finally, I'm returning this function props object. So that's it in this config file. Let's go back to our stack file and use these functions to define our Lambda functions in the stack. Let's first import the two functions we created from Lambdaconfig. Now I'm fetching my Lambda definitions using the getLambdaDefinitions function we just imported. And I'm passing in the context object to the function. Now I'm just looping through the definitions using a for loop. And first thing we need to do within the loop is to fetch the function props based on the Lambda definition. As you can see, I'm passing in Lambda definition, a Lambda role, Lambda layer, and context. And this will return as a function props object. Next, we are checking if isPrivate is set to true and add additional props required to create the function within the VPC, which is basically called as a private function. Here we're just spreading the existing function props returned from the get function props function and add additional props for VPC security groups and subnets. And the last thing we need to do is to create an instance of Node.js function and pass in the function props. And as you can immediately notice, our stack file is clean and concise, and all we need to do is to modify our Lambda definitions array in our config file to add new Lambda functions. And one last thing you can do is to add a log group for your Lambda functions. By default, the log groups are created by Lambda functions won't have any retention period set, and your logs will be there forever, which can bump up your cost quickly if you have hundreds or even thousands of Lambda functions. So I would always prefer to add a retention to my Lambda log groups or any other log groups as per your requirements. So first, let me import CloudWatch logs from CDK lib and define a log group within our for loop. I'm setting the log group name to /AWS/Lambda/function name. Make sure the name is in this format, as Lambda uses this format to generate the log groups. Then I'm setting the retention to 1 month. You can also define this in your Lambda definition as well if you want to set different retention for each of your Lambda functions. I'm also setting the removal policy to destroy, as by default when you delete a stack, the log groups are retained. You might need to set this as per your requirements. So that's our stack file. Now let's quickly add some sample code to our Lambda functions. And before that, let's install a package called AWS-Lambda, which provides us with all the types required for Node.js based Lambda functions. So I'm installing AWS-Lambda and corresponding types. Now let me first import a generic handler from this package in our Lambda function. Apart from generic handler, you can see that this package provides us with other handlers like SQS, S3, Kinesis, API Gateway, and many more. And for this demo, I'll just use the generic handler. Next, I'm pasting some boilerplate code to define our handler. I'll just print some log messages for demonstration purposes in this Lambda function. And we can utilize the logging functions we defined in our Lambda layer for this. As you might already know, our Lambda layer will be mapped to /opt directory within our Lambda runtime. So let's import our utils from /opt. You can see that TypeScript is showing an error as /opt is not present on this local machine. To fix this, we can add base URL and path mappings to our tsconfig file. This basically tells TypeScript to map files within this Lambda layer directory to /opt. Now that TypeScript error is gone. Now we can utilize the logging functions from utils file within Lambda layer. So I'll just log a message. I'll copy the same code to the public function as well and change the message. We have now defined all the resources required to deploy our Lambda functions, and we have some sample code within our Lambda functions as well. Now let's see how we can execute these Lambda functions locally for testing and debugging purposes. Make sure you have set your AWS profile correctly and execute CDK list to list the stacks. We can see our stack name, which is ts-lambda-stack-develop. Next, we need to run the CDK synth command, which generates a CloudFormation template based on the CDK code. Here I'm specifically synthesizing Lambda stack and sending the output to a file called template.yaml. As we only have one stack, it won't make any difference even if we don't specify the stack name. But if you have multiple stacks and you want to synthesize only Lambda stack, you need to specify the name of your stack. The no staging option is just for local debugging. It will disable copying the assets to your cdk.out directory, and we need the assets only when we deploy these stacks. So we provide --no staging option when debugging locally. So we have our template.yaml file created, and all the resources we defined in our stack can be found here. We can see our IAM roles, IAM policy, security group, Lambda layer, and finally our 2 Lambda functions and 2 log groups. So to test these functions locally, we can use samlocal using the function ID from the template. For example, to execute the public function, we can simply copy the public function ID. and run SAM local invoke and then the function ID. If you don't want to pass any event, you can pass -- no event, or if you do want to pass any event for your Lambda function, you can use -- event option to pass an event. Make sure you have SAM CLI and Docker installed on your local machine before invoking SAM local. So it will first build the image if you don't have one already and executes the Lambda function and prints the output on the screen. So it will give you some Lambda specific metrics as well, like initialization, duration, actual duration, build duration, and memory. So that's how you execute individual Lambda functions locally using SAM. So that's how you develop and test your Lambda functions locally. And once you're happy with the output of the Lambda functions, you can use CDK deploy to deploy your stack. You can see that our deployment failed, and you might know the reason already based on the messages you saw on the screen. As we are creating private Lambda functions, we need to provide necessary permissions to the Lambda role to create network interfaces. And AWS provides a managed policy with necessary permissions to create private Lambda functions, and it's called AWS Lambda VPC Access Execution Role. Let's go back to our stack file and add the ARN of this policy to our Lambda role. We can use from managed policy ARN method and pass in the ARN of the managed policy as shown here. Now let's attempt CDK deploy again, and now the deployment is successful. If you see any errors at this stage, you can try deleting the stack from the console and execute the CDK deploy command again. And the private function creation might take some time as it needs to create some additional network interfaces within your VPC. Now let's quickly log into the console and have a look at the resources it created. Under CloudFormation stacks, we can see our stacks, which is called ts-lambda-stack-develop. And if we go to resources, we can see all our resources created. Let's quickly check our Lambda functions. Let's look at the public function first. You can see the compiled version of TypeScript file here. And under config, we can see our environment variables defined in the Lambdaconfig. And we can also see the common environment tag we added for all the resources in the stack. If we take a look at the private function, we can see the VPC, subnet, and security group config as expected. Also under general config, you can see the non-default values for memory and timeout. For public function, we should have the default values of 1024 megabytes for memory and 15 minutes for timeout. So that's it for this video. That's how you can develop, test, and deploy your TypeScript-based Lambda functions using AWS CDK. Hope you found it helpful. Please like and subscribe to my channel if you did. Thank you for watching, and see you in the next one.